Hello, everybody. Welcome to the Advances in Research and Innovation stream of the SNOMED CT Expo 2022. My name is Kai Keeley, and I am a technical implementation specialist with SNOMED International. I'll be moderating today's session. All questions will be answered at the conclusion of the presentation, and online attendees, please use the Q&A box to type your questions to the presenter. And on-site attendees, please use the microphone provided. I'm now pleased to introduce Javier Castell Diaz from the University of Murcia, who will be presenting towards the automatic building of SNOMED CT post-coordinated expressions.
Thank you. So, hello, my name is Javier Castell Diaz. I'm a predoctoral researcher at University of Murcia, and I'm going to present our current research about the automatic building of SNOMED CT post-coordinated expressions. Next, please. So, as you already know, SNOMED is a medical terminology that represents clinical knowledge through an ontology. As a medical terminology, it is impossible to cover every term to be able to represent any type of information. So, SNOMED has the post-coordination mechanism, which allows us to create new concepts from previously existing ones with previous relationships. However, it is hard to perform post-coordination manually, since there's a lot of concepts and you need to have some expert knowledge about the domain. Next, please. So our objective is to support this automatic post-coordination by presenting some type of method that can help an expert perform this task. What we want is, if we have an expression of a term, we want to transform that to its corresponding post-coordinated concept. Here we have an example. For the concept left breast biopsy, there is no pre-coordinated concept, but what we want to obtain is that left breast biopsy is a procedure, that it is a type of biopsy of breast, that it has a relationship method with biopsy, and that it has a relationship procedure site with left breast extractor. Next, please. So this method uses word embeddings or knowledge graph embeddings, and I'm going to give a brief explanation on them. Word embeddings allow us to represent words as an array of numbers, as a vector of real words, but keeping the semantic information and the underlying relationships. Here we have Spain, Madrid, Portugal, and Lisbon. And if we measure the distance in the vector space between Spain and Madrid, between Portugal and Lisbon, the distance should be the same as it is representing the relationship between a country and its capital. Next, please. We can then use this to perform analogies, to identify new relationships between concepts, or to find new concepts for a relationship. Here we have the concept arm and hand and the concept leg. If we measure the distance in the vector space between arm and hand and apply it to leg, next, please. Next again, please. We will find that the closest concept should be foot. Next again, please. So this is an overview of our system. I'm going to go into more detail later, but we can identify 3 different parts. Next, please. The first one is the previous one. No, back. Yeah, thank you. The first step is the corpus generation. We want to, from SNOMED, obtain some type of corpus. We do this by performing random walks on each concept in SNOMED. And then we transform that to a couple of sentences that make our corpus. Next, please. With this corpus, we train a language model, an embedding model. And once we have our trained model, what we do is create a dictionary of vectors that associate each concept with its embedding. Next, please. Finally, we have the post-coordination itself, where we use these previously created embeddings to obtain the post-coordinated form. Next, please. Now, Okay, the first step is corpus generation. So as I said, we want to obtain sentences from SNOMED by performing random walks. What we do is, for each concept in SNOMED, we perform a random walk, and then that sequence of identifiers, we transform it to a sentence using the descriptions. So here we have the concept common cold. Next, please. An example of a random walk could be common cold, causative agent, virus. Next, please. So, okay, the boxes should be arrows, but you can imagine it. We have a sequence of identifiers, but we want to transform that into a sentence in natural language. So what we use is the description, the synonyms. In this example, for common cold, we can call it common cold or acute rhinitis. And for virus, we can only call it virus. So from this particular example, we would obtain two different sentences: common cold, causative agent, virus. Next, please. And acute rhinitis, causative agent, virus. Next again. Now, the next thing is embedding model training. We take that corpus and we use it as an input for our language model to train it. We also tried some pre-trained language models such as BioBERT or Moon that did not need our corpus. And once we have our model ready, we create a dictionary of vectors that, as I said, it associates its concept to an embedding using the fully specified name. Next, please. Okay, so now we should go into the postcoordination itself. How do we do it? We perform a set of different steps, and we are going to follow this process for the example manipulation of stomach. I know manipulation of stomach is a pre-coordinated term, but this is just an example, okay? The first thing is we want to obtain the embedding for manipulation of stomach. So we just take the sentence manipulation of stomach and pass it through the language model, and we obtain that, that vector of numbers. Next, please. Now we want to obtain the semantic type for our concept. What we do is look at the 5 most frequent concepts in the dictionary using the embeddings. We measure the similarity using cosine distance, and we find the most frequent semantic tag among them. Here we have 3 procedures, so our manipulation of stomach is going to be a procedure. That second concept, which is in yellow, is what we call the reference concept. It is the most similar concept that shares the semantic type that we have selected. We are going to use that reference concept as a template to obtain the relationships. Next, please. Here, our reference concept is esophagus manipulation. It has 3 relationships: ESA, procedure, site, and method. So we just take those relationships and we add it to our manipulation of stomach concept. Next, please. Now we have to identify the tail concept for each of these relationships. Here is where we use analogies. In this example, for the procedure site relationship, we will look at the distance between esophagus manipulation and esophageal structure. We would add that distance to our embedding of manipulation of stomach, and we would look for the most similar concept to that point in the embedding dictionary. We are also constraining ourselves to some concepts by using the SNOMED logical model. Here, for example, procedure site does not allow a tail concept of a situation type, or a situation semantic type. So we filter them out and we will take the next one, which in this case is stomach structure. Then this is repeated for each of the relationships. Next, please. Until we have our fully post-coordinated concept. Next, please. Okay, to evaluate our method, we define 3 sets of concepts, of pre-coordinated concepts: training, validation, and test. Training was used for training the method. Validation was to identify the different values for the parameters of our system, and test was just left out to have a final set of concepts for final performance results. We have focused on the we have focused on the Spanish version of SNOMED CT, but we have also done some testing on the international English version. As for the metrics we use, we have created 4 metrics. The first 3 ones are semantic type accuracy, relationship accuracy, and analogy accuracy, each measuring how many correct semantic tags, relationships, and analogies we have obtained. And the final one, completeness, aggregates the previous 3 to obtain some kind of general idea of how well it creates the final post-coordination. Next, please. Okay, so the idea behind our corpus was, if an embedding model learns to represent words by its surrounding words, and in SNOMED a concept is represented by the relationships to other concepts, we can try to combine this to represent a concept in itself through an embedding. So we created, for example, two corpora to identify the differences between using all relationships in SNOMED and only using essay relationships. Here we find that for semantic tag accuracy and relationship accuracy, the results were very similar. But if we look at the analogy accuracy, there's a 10% difference between using all relationships and only using essay relationships. This is to be expected, since by using all relationships, we are teaching our model how concepts of different semantic types are related between them. As for completeness, well, we got a little about 50% in completeness, just as we expected, looking at the previous results in semantic tag accuracy, relationship accuracy, and analogy accuracy, because it's mistake in one of those metrics is adding up. Next, please. To try to improve our results, we decided to just check different embedding models. We tried word-to-vec, fast text, and different BERT-related models. Of the BERT-related models, we use only pre-trained models, except for Beto, which is a version of BERT trained in the Spanish version of Wikipedia. We found that the best results for Spanish were with trained Beto, but there were not that many differences apart from using semantic tag accuracy compared to, for example, fast text, which were the previous results we saw. Next, please. As I previously said, for the test set, we decided, okay, let's try to use the international English version. Here we use the pre-trained SBERT version, and the results we obtained were really similar to what we had already seen in the validation set. Next, please. We also compare our method with other state-of-the-art methods, such as, for example, O2Vec, because our corpus generation is really inspired by what they did. So we created a corpus of SNOMED using O2Vec star, and we added to our system to identify the results. The main difference between our version and O2Vec star version is that they actually consider the axioms of the ontology when creating the corpus, while we don't know. We do not. Looking at the results, we found that they were really similar, and in the analogy accuracy, we obtained slightly better results. We think that actually by adding the axioms of the ontology to the corpus, they are only adding noise. Next, please. Finally, we compare our results to a method proposed by Kate that is also about the conversion of of expressions to post-coordinated concepts. And we compare our results using a small data set of only 35 manually post-coordinated concepts that they will develop for their work. We also use their metrics, which are full conversion rate, that does not allow any type of mistake in the post-coordination, and partial conversion rate, which allow us at most one mistake. Looking at the results, well, we were able to outperform them both for full conversion rate with fast text and with partial conversion rate with both fast text and SVERT. Next, please. This is an example of a manually post-coordinated concept from the dataset on the left side for candidal esophagitis, and on the right side is what we obtain with our method. This is a case of a partially converted concept, as we were not able to identify the relationship causative agent. We also identified two relationships that they did not take into account, like pathological process and associated with. And instead of using the more general disease as the parent for the easy relationship, we selected infective esophagitis for this particular example. Next, please. Now, our method does have some limitations. We were able to obtain good results for both semantic tag accuracy and relationship accuracy, but the relationship accuracy is really limited, since we select the relationships by trusting that our reference concept is going to have a similar structure to our target concept. And this is going to be true in most cases, but there are some instances where the concept needs a less frequent structure. For example, bilateral carotid bruit requires two finding sites. And this is a pattern that can be found in SNOMED, but it is not that usual. We also have a problem if we do not identify the semantic tag correctly, because the whole process is going to collapse, as we depend on that semantic type to identify the reference concept to then identify the relationship. So a wrong semantic tag is going to be a wrong reference concept with a obviously wrong structure. Another problem we have is, well, a limitation, is that there's a lack of annotated corpora with post-coordinated concepts. We have tested our method only with pre-coordinated concepts, because we were not able to find many datasets of post-coordinated concept. We only tested it on the dataset created by Kate's work. Next, please. So to round things up, we were able to implement a method that, given an expression in natural language, it suggests post-coordination. Okay, we remark the suggestion part, as it should be revised then by an expert. This is not automatic yet. We were able to test it on the Spanish and International English version of SNOMED, and we think we obtained good results for being our first approach. As for further improvement, we think that the worst aspect of our method is the analogy accuracy. Is where we are having more problems with the tail concept selection. So maybe by training a neural network to use the relationships explicitly, we could improve the results, or maybe just trying other language models that we have not considered. Next, please. So that's all, and thank you for your attention.
Thank you, Javier. That's fascinating work. I can imagine a kind of semi-automated, authoring of concepts. Yeah, it could be a really useful, interesting proof of concept. We're going to take some questions now. I'm sure there are some. If not, I've got some. I'm not using the pre-canned ones. They're awful. So you mentioned that there was an algorithm that you were comparing against that actually used the OWL axioms, and it classified or did some reasoning. Are you doing any reasoning before you evaluate your results? Like, are you classifying your post-coordinated expressions and then evaluating the inferred relationships?
No, we are not performing any type of reasoning for the relationships we extract or anything we have done.
Yeah, because you may find that just by, well, depending on if you're using role groups or not, you may find that just by classifying, you actually get a more complete set of relationships, and it may boost your results.
Okay, thank you. This is something that we will consider.
Yeah, I really enjoyed that. Wondering because the semantic tag selection is so crucial to the downstream steps, did you do any error analysis on, when it went wrong, how that was linked back to your process of selecting the semantic tag where it was, the average of the top 5?
We did some tests. Actually, the first version, we just simply took the semantic tag of the most frequent concept, but we found out that if we look at the top hits at 5 and 10, we obtain better results. So we decided, okay, let's try to add that to our method. And we thought that about the choosing the most frequent. We tried the most frequent at 5 and the most frequent at 10. And the results were better than using only the first one, but really similar. So we said, okay, let's just look at the top 5 and keep that.
I've got a couple of questions from online. There's a question here from John Snyder. Were both primitive and fully defined concepts used as reference concepts? And if both were used, how would the results have been different if only fully defined concepts were used?
Okay, so for validating the results, we had to be careful for what concepts we were choosing. You cannot take a navigational concept that only has an easy relationship and use that to compare the results we obtain, because we need those relationships. So we also perform a filtering by taking a pre-coordinated concept that at least had one relationship different from the easy relationship. So just to try to have something more interesting to post-coordinate.
Yeah. Is there any more questions in the room? Yeah.
Thanks. This is really a question for him, but I'll put it to you and then he can maybe answer it.
Okay.
And my question is, why aren't there any post-coordinated expression corpuses that you could use to test your thing? Because I think we have one, but why don't you have one? Or are you in a sort of a bubble university with nobody actually producing the corpus for you?
Okay, so I don't think that our Kati maybe can answer that.
Yeah, I don't know if I got the question. So
I'm ready.
She is my PhD tutor, so she was the
yes,
one
I'm
leading
the
the
supervisor.
investigation.
So if it's blaming, it's me. But I'm not sure if I got the question. So it was about corpus of post-coordinated expressions. Yeah, so we don't have access to corpus of post-coordinated expressions, especially in Spanish. I think that's challenging. So then we had to use SNOMED CT. So just part of SNOMED CT as the ground truth. And then the only corpus that we found on the internet was this one of this work from Kate. So if there are other corpus available, especially, okay, we focus on Spanish, but we are also doing it for English. So happy to to see them and work with them, because this will allow us to improve the method, in fact. So the more examples you have, the more the method can learn. So that's the way of doing it.
One more question.
Yeah, I noted that you excluded the causative agents, the organisms, and wasn't quite sure what the reason was about that. I wonder if you had anything more to say about the issues that you encountered with that.
You mean in the example, the previous example for the? Okay, can you go back some slides?
Yeah, you had a slide where
one more, and you mean this one? Okay,
Yeah.
so I don't remember what was the reference concept we selected, but since the reference concept we selected using our method to obtain for candidate esophagitis, that reference concept did not have the causative agent relationship. If the reference concept does not have the causative agent relationship, we cannot apply it. That's why we did not use it.
Okay.
But if the concept itself had it, we would have added it to a target concept.
I know there's more questions in the audience, and I've got to apologize to Jay Kaler online. If you have more questions, please reach out either to myself or to Javier, and we can get those answered. But we've run out of time, unfortunately. But thank you very much for your talk.
Thank you.